typical MIG welding issues and their solutions. Hi friends, welcome to our video guide on MIG welding challenges. Today, we're diving into a comprehensive list of common issues you might encounter while using a MIG welder, along with effective solutions for each. This guide is designed with beginners in mind, ensuring it's straightforward and easy to grasp. We'll cover a range of problems from wire feeding difficulties to maintaining a stable arc, and much more. So, whether you're new to welding or looking to brush up on your skills, this video has got you covered. Let's get started on your journey to becoming a proficient MIG welder. Wire feed issues. Let's begin with wire feed challenges, a common hurdle in MIG welding. If your wire isn't moving smoothly as it should, several factors could be at play. Think of it as a bicycle. If the chain isn't moving correctly, it affects the whole ride. Similarly, in welding, if your wire is tangled, it disrupts the flow. Take a moment to inspect the wire spool. Is it properly mounted? Are there any knots or kinks? Next, turn your attention to the feed rollers. They play a crucial role, just like the gears on a bike. If they are too tight, the wire can be crushed. Too loose, and it won't feed correctly. Adjust them carefully, ensuring they are neither too tight nor too loose, and match to the wire size you're using. By keeping these components in check, you'll ensure a smoother welding experience. Irregular arc. Now, we move on to the issue of an irregular arc in MIG welding. Imagine a light bulb in your home that flickers instead of giving a steady light. This is similar to what happens when you experience an irregular arc while welding. The arc, instead of being stable and continuous, fluctuates, making it difficult to weld properly. To fix this, the first thing to check is the power supply to your welding machine. An unstable power source can cause the arc to be inconsistent, just like fluctuations in your home's electricity can make a light bulb flicker. Ensure that the power supply is reliable and delivering a consistent current. Another important aspect is the earth clamp, also known as the grounding clamp. This needs to be securely attached and in good condition. The earth clamp works like the socket for a light bulb. It needs to have a good connection to function correctly. If the clamp is loose or not properly connected, it can lead to an irregular arc. So, make sure it's tightly fixed and has a clean, strong connection to the material you are welding. By ensuring both a stable power supply and a secure earth clamp, you can achieve a steady and reliable arc for your MIG welding tasks. Too much spatter. Our third topic is the issue of too much spatter in MIG welding. Spatter refers to the small droplets of molten metal that are thrown from the welding area during the process. It's similar to how paint splatters around when you're painting a wall vigorously. These droplets can be messy and may affect the quality of your weld, just like how paint splatters can spoil the finish of a wall. To tackle this issue, a key factor to consider is the adjustment of your welding voltage and speed. Think of it like tuning a musical instrument to get the right sound. If the voltage is too high or the speed of your wire feed is too fast, it can cause more spatter. You want to find a balance where the metal melts smoothly at the point of contact without excess splatter. Another important aspect is the quality of the welding wire you're using. High quality wire tends to produce less spatter compared to lower quality ones. It's like using good quality paint for a smoother finish on your walls. A good wire has fewer impurities, which helps in creating a cleaner weld with minimal spatter. By carefully adjusting your voltage and speed, and using high-quality welding wire, you can significantly reduce the amount of spatter and achieve cleaner, more precise welds. This not only improves the appearance of your welds, but also reduces the cleanup work afterward. Weld porosity. Now, let's discuss weld porosity, a common challenge in MIG welding. Imagine a sponge with its numerous tiny holes. Weld porosity is similar, where your weld contains tiny holes or voids. These holes are usually not visible on the surface, but they weaken the weld, much like how the holes in a sponge make it less solid. Porosity in welding occurs when gas gets trapped in the molten metal as it cools and solidifies. The main cause of this gas entrapment is often related to the welding environment and technique. For instance, if you're welding in an area with a lot of wind or drafts, the shielding gas that protects the weld from atmospheric contamination can get blown away. This is like trying to cover something in a windy environment. The cover doesn't stay in place, leaving the item exposed. To prevent weld porosity, the first step is to ensure your work area is wind-free or shielded from drafts. If you're working outdoors, you might need to set up some form of wind protection. Another crucial factor is the correct setting of your gas flow. The flow of shielding gas needs to be consistent and at the right pressure. If the flow is too low, it won't adequately protect the weld pool from atmospheric gases. On the other hand, if it's too high, it can create turbulence and draw in unwanted air. It's a bit like watering plants. Too little water and the plant dries out. Too much and you flood it. Finding the right balance is key. By ensuring a protected work environment and correctly setting your gas flow, you can greatly reduce the risk of porosity and achieve stronger, more reliable welds. Burn-through. Let's talk about burn-through, a frequent concern in MIG welding, especially for beginners. Burn-through is similar to the way sunlight focused through a magnifying glass can burn a hole in a piece of paper. In welding, it happens when the heat is too intense for the metal you're working on, causing it to melt and create a hole. This issue is more common when welding thinner metals. These metals, like a thin sheet of paper, can't absorb a lot of heat without being damaged. The key to avoiding burn-through is managing the heat input. You need to find a delicate balance, much like adjusting the brightness of a light to ensure it's neither too dim nor too bright. Firstly, consider using lower heat settings. In welding terms, this means adjusting the voltage and amperage down. It's like using a gentle flame to warm something instead of a high, intense flame that could burn it. Secondly, you need to weld faster. This doesn't mean rushing your work, but rather moving the welding gun at a speed that doesn't allow the heat to concentrate in one spot for too long. Imagine running your finger through a candle flame quickly enough that you feel the heat but don't get burnt. Also, practicing good welding techniques, such as maintaining a consistent speed and distance, can help prevent burn-through. It's like learning to glide smoothly over ice without digging into it. By using lower heat and moving the welding gun faster, you can prevent burn-through and ensure your metal stays intact, leading to a stronger and more aesthetically pleasing weld. Inconsistent wire speed. Now, let's address the issue of inconsistent wire speed in MIG welding. Imagine you're riding a bike and suddenly the pedals start slipping. This inconsistency can throw you off balance, similar to how inconsistent wire speed can affect your welding quality. Inconsistent wire speed in MIG welding can lead to a range of problems, from irregular arc stability to inconsistent weld penetration. It's like trying to draw a straight line with a pen that keeps skipping. The result is uneven and unsatisfactory. The first thing to check is the drive roll pressure. The drive rolls push the wire through the welding gun. If the pressure is too high, it can crush or deform the wire, leading to resistance and speed variation. On the other hand, if it's too low, the wire might not feed consistently. It's similar to the tension on a bike chain. Too tight and it can jam. Too loose and it slips. Next, ensure that your wire spool isn't obstructed or tangled. An obstructed spool is like having something stuck in your bike wheel. It can cause the wire to jerk or stall as it feeds, disrupting your welding rhythm. Make sure the spool can rotate freely and the wire unwinds smoothly without any snags. By ensuring the correct drive roll pressure and a freely moving wire spool, you can achieve a consistent wire feed rate. This leads to smoother, more stable welding, much like how a well-tuned bike provides a smooth ride. Remember, consistency is key in achieving quality welds. As we come to the end of our discussion, we've tackled some of the most common MIG welding problems and shared solutions to help you overcome them. But remember, the right equipment plays a crucial role in your welding experience. For those looking for a reliable and user-friendly option, I'd recommend considering the Crux Weld MIG welding machines. These machines are designed with both beginners and experienced welders in mind. They incorporate features that address many of the issues we've discussed, from wire feed challenges to managing spatter and ensuring consistent welding quality. Thank you for joining us in this informative session. We hope these tips and solutions make your MIG welding tasks easier and more efficient. Stay safe and keep crafting those strong, beautiful welds.